We're going to look in this video at how we graph rational functions, which is one of the last topics in the course, looking at functions that are written as fractions and looking at them and figuring out what the domain is, what the range is, looking at where the asymptotes are and coming up with a picture. So what I started with first is just a little list to give you an idea of what the expectation is when you take a quiz or when you take a test. Given any rational function, you should be able to, and it's kind of taking you through the list, and this is how it will be graded as well. You should be able to find where all of the vertical asymptotes are, and to give you an idea of how you do that, that is where the denominator equals 0. Sometimes you have to factor the denominator, sometimes it's already ready to solve and set equal to 0. You also need to be able to find the horizontal asymptotes. Horizontal asymptotes are going to focus more on the degree, looking and seeing, do we have a bigger degree on top, on the bottom, are they the same? And I'll take you through all different examples of horizontal asymptotes. You should be able to state the domain. The domain would be the numbers except for where there's a vertical asymptote. You should be able to state the range, which is a lot of times a little more complicated because you have to think about the horizontal asymptotes, but you also have to look at the picture because some of the graphs aren't as obvious as they may seem. And then finally, putting all that information together, you should be able to draw a graph. So I'm going to go through 5 of them for you, and we're going to do that same series of questions. We're going to look at the asymptotes, the domain and range, and then when we're done, we're going to make sure we have an accurate picture. So the first one we have is the simplest one, what we first started with, negative 5 over x minus 3 plus 4. I'm going to start with vertical asymptote because we do not need our calculator for this. Vertical asymptote is going to be whatever makes the denominator 0. So if you look at x minus 3, what will make that 0 is x equals 3. And so immediately I'm going to go onto my picture and I'm going to draw my vertical asymptote. Horizontal asymptote, this is also one of our easier ones. Whenever you have it written like this, when you have a number in the numerator over a linear piece, x plus something or x minus something, and then something at the end, the horizontal asymptote will just be this end value. So in this case, it's just y equals 4. And again, on my picture, I'm going to draw that. This one was a little easier because we consider this just a basic hyperbola. My domain is going to be everything except for where you have the vertical asymptote. So you can write a lot of ways. You can say all real numbers except x can't be 3, or you could say from negative infinity to 3 and then from 3 to infinity, or you could say x is less than 3 and x is greater than 3, but this is probably the simplest way to do it. My range will also just be everywhere except for your horizontal asymptote. So all real numbers except y can't be 4. And again, this is because this is a basic hyperbola. And then to draw the graph, we actually have a pretty good idea what this looks like prior to using my calculator because it has a negative up with the 5. You actually have the branches kind of flipping. But if you're unsure, you can go to your calculator, type in negative 5. When you type in your calculator, it's very important to make that denominator be in parentheses. Any type of part that is more than just a single term needs to be in parentheses. And then plus 4. I'm going to zoom 6. You see one branch there, you see one branch there. So on my picture, I'm going to come in and draw it and kind of use the asymptotes as like a guide, a grid to help you follow it. And that is your hyperbola. So this is the most basic type that you'll see. Very quick, really don't need the calculator for much other than to make sure your picture is accurate. The second one, this is also a hyperbola. This is a situation where we have a linear piece on top. So you have something with an x and a linear piece on the bottom. For this one, vertical asymptote is still what makes the denominator 0. So if you needed to go off to the side and write 3x plus 4 equals 0, or if you can do that in your head, it happens at negative 4/3. X equals, because it's a vertical line. So I'm going to go to negative 4/3 would be a little bit to the left of negative 1. There's my asymptote. My horizontal asymptote is a little different with these. My horizontal asymptote will be the ratio of the leading coefficients. So it's going to be how many x's on top divided by how many x's on the bottom. You end up getting y equals 2/3. Putting that on my picture as well. As you find something out, put it on your picture. Because this is just a hyperbola, my domain is still just all real numbers except x can't be negative 4/3 because that's where the vertical asymptote is. And my range is all real numbers except y can't be 2/3. Go to my calculator. Here's the calculator, a little more helpful with this one because it gives you an idea of where to put the branches. When you enter it in your calculator, you have to put the top and the bottom in its own parentheses. So 2x minus 1 needs to be in parentheses, and then divided by 3x plus 4 needs to be in parentheses. If you don't put parentheses around one of them, or you don't put parentheses around either of them, you get a very different looking picture. So here is one branch, here is the other branch, and you can see it kind of just works right in with the asymptotes that I already drew. So the first two, basic hyperbola, probably the easiest ones you're going to go through when it comes to finding asymptotes in domain and range. The ones that are a little more complicated are the ones that you have not just linear pieces. So you start to have things that have an x squared in it or an x cubed in it, where you have to go do a little bit more work, especially for the horizontal asymptote and for the range. The vertical asymptote and the domain is actually still the same thing as what we've been doing. So we're going to start with vertical asymptote. Again, vertical asymptote is what makes the denominator 0. Now I do have to factor this, or you could use a quadratic formula. It factors x plus 3, x minus 2. So that means I have two vertical asymptotes at x equals negative 3 and x equals 2. So on my picture, I'm going to put an asymptote here at x equals 2 and an asymptote here at x equals negative 3. When you have pieces that aren't linear, you have the potential of having more asymptotes. My horizontal asymptote, now I have to use my degrees as a guideline. And here's where you just have to go through and practice it and try to remember the idea of what you're comparing. If you have a bigger degree on the top, you have no horizontal asymptote. That doesn't happen here. We actually have a bigger degree on the bottom. If we have a bigger degree on the bottom, like the one we're looking at, my horizontal asymptote is y equals 0. The other option is if we have the same degree, and we're going to do one of those in a little bit, but it's like what we just did on the last slide. Use the ratio of those leading numbers. So my horizontal asymptote is y equals 0, which is going right along the x-axis. My domain is still everything except for where I have those vertical asymptotes. But the range is more challenging. The range will not necessarily be everything except for y equals 0. You have to look at the graph. So I'm going to go on my calculator, go to y equals, type in 3 divided by, and then make sure you use parentheses, putting that entire denominator in its own parentheses, x squared plus x minus 6. Close your parentheses, hit graph. This one actually, this is not a hyperbola. This is a very different looking graph. This graph is actually made up of 3 different pieces. We have this piece, we have this piece, and then in the middle, just to kind of give you a look of it again, you have almost like, it almost looks like a parabola upside down, kind of a U-shaped piece in the middle. My range, what you'll notice on this one is my range is the y value. So it's looking above, looking up and down. My range on this one is everything is above 0. You can see. It's also everything below 0. The only thing that it doesn't include is it does not include 0. So this is an example. It actually ends up being what some of the earlier ones were, but we really have to look at these to see, is there any type of gap in my range? The only gap in my range here is you'll never have a height of 0 because you have that asymptote there. So it is everything except for 0. But you want to look at these because sometimes you'll have a little bit of a gap forming where that middle piece may be a little bit lower, so your range will have an empty area in there. So you really want to look at those. This one, 6 over x squared plus 9, my vertical asymptote is what makes the bottom 0. And if you look at the denominator here, this will not factor. If you try to set it equal to 0, you have x squared plus 9 equals 0. What's going to end up happening is you're going to get an imaginary. And since we are not working with imaginary, we just say we have no vertical asymptotes or none. My horizontal asymptote is like the last one. I have a bigger degree in the bottom, so it'll be y equals 0. So I'm going to put my dotted line here at y equals 0. My domain, because I have no vertical asymptotes, is all real numbers. There's no exception. And my range is going to come from the picture. So going back to my picture, graph this function, 6 divided by parentheses, x squared plus 9. X squared plus 9. Close my parentheses, hit graph. Kind of a strange looking graph. You actually can't see anything in much detail. I'm going to go to my window. I'm going to make it a little bit smaller. So instead of going from my y minimum negative 10 to 10, I'm going to go from negative 3 to 3 just to get a better visual of what's happening here. Here's my graph. What ends up happening is it looks like this. Kind of comes up and then comes right back down. I want to see what that highest point is, so I want to know this point because that's going to help me with my range. So if I go to trace, it will actually tell me it's kind of flashing on that point, which is nice because it immediately goes to when x is 0. I get y equals 0.666 or y equals 2/3. So this is the point 0, 0, 2/3. Another thing we can do is we could just plug 0 in for x into the original equation, and we get 2/3. The reason that's so important is that's telling me about my range. My range, this graph is kind of like sandwiched between things. It's always above 0, but below 2/3. So there's a lot of ways to write this. One way to write it is you could say that it goes from 0 to 2/3. Notice the way I wrote it, 0 is not included. There's an asymptote there, so that's why I put parentheses. 2/3 is included. That is an actual point on the graph. So you put 2/3 and you put a brackets there. You could also say that it is y values that are between 0 and 2/3, but you have to put the or equal to here because it is including 2/3. You can say it in words that it is any y value that is bigger than 0, but less than or equal to 2/3. And then the last problem we're going to go over, another rational one, a little different scenario here. We have a bigger degree on top. My vertical asymptote is what makes the bottom 0, so that one is just x equals -2. Don't really have to do a lot of extra work because it's a pretty simple denominator. My horizontal asymptote is going to come from looking at the degree. This time we have a bigger degree on top. When you have a larger degree on top, there is no horizontal asymptote, so I'm just going to write none. My domain is all real numbers except x can't be -2. And my range is going to come from looking at the picture once again. So I want to put the numerator in parentheses. X squared plus 3x minus 2. And then denominator in parentheses, x plus 2. Hit graph. So my graph, it looks like what's happening is it's getting really close to the vertical asymptote and going out like this. And then on the other side, it's getting close to the vertical asymptote coming this way. What you'll notice is as far as range, the graph extends up and down in both directions forever. There's actually no issue with my range here. This is an example of one that would have what's called an oblique asymptote, which is not something that we're finding in this class. You'll do more of that in like a pre-calc class. My range then is all real numbers. So this takes you through all of the different examples that you could have. Every rational function, you should be able to answer those same series of 4 questions. Where are the vertical and horizontal asymptotes? What's the domain and what's the range? And when it's all said and done, you should be able to put a picture that's pretty accurate looking onto a graph and see what actually is going on.